Hello student, the last class I discussed the introduction of a solid and we started the unit cell. So let us focus on the unit cell. The unit cell, if you look at this unit cell, there are one-dimensional unit cell, two-dimensional unit cell and three-dimensional unit cell is there. In one-dimensional unit cell, 1D unit cell means one-dimensional unit cell. Suppose that means only one layer of arrangement of atoms will be there like that. So one layer of arrangement of atom will be there like that. So that is why to measure this one-dimensional unit cell, only one type of parameters is required. That means the distance between the two atoms. Like that is nothing but the parameters I am telling A, the distance between the two atoms. That is why A is a distance between the two atoms. That means in one-dimensional unit cell, you need only one parameters. But in case of a two-dimensional unit cell, dear, if you look at my dear, so in two-dimensional unit cell, what is happening? One layer of atom is there like this, and then the second layer of atoms also will be there like this. The second layer of second row will be there like this. And then because of that, if you look at to define this two-dimensional unit cell, there are three parameters is required. One distance is this, another distance will be this, and in between angle theta. There are three parameters is required, A, B and theta. So now that is why there are certain varieties of unit cell is possible in two-dimensional unit cell. One is I am writing square unit cell. In square unit cell, what will be there my dear? In two-dimensional square unit cell, it will be looking like this. All the points there will be atoms. This is a unit cell. Like that, this will be repeated. Now this is unit cell. You look at, this is repeated. So this square unit cell, this is this and this angle I can take theta. So then A will be cos to B and theta will be cos to what? 90 degree. So these are the things you know. This is a square unit cell. And moreover, then we can write down rectangular unit cell. Rectangular unit cell. In rectangular unit cell, already you know rectangle means what? Like this is A and this is B and in between angle theta. So then A not equals to B, theta equals to what? 90 degree. So that means in rectangular unit cell, A not equals to B, theta equals to what? 90 degree. And then third category is hexagonal unit cell. In hexagonal unit cell, what will happen? Hexagonal unit cell will be like this, This is a theta, this is A equals to B. Here A equals to B, but theta equals to nothing but a 9, not 90, it will be 60. And now fourth one is nothing but a rhombic unit cell. In rhombic unit cell, what will happen? That A will be equals to B, but theta not equals to 90, theta not equals to 60. That is nothing but a rhombic unit cell. So that means in a square unit cell, A equals to B, theta equals to 90. Rectangular unit cell, A not equals to B, theta equals to 90. Hexagonal unit cell, A equals to B, theta equals to 60. But rhombic unit cell, A equals to B, theta not equals to 90, not equals to 60. And fifth one is nothing but a parallelogram. In parallelogram unit cell, what will be there? A not equals to B, theta not equals to 90 and theta not equals to 60. So that means these are the things you have to understand. So that means there are 5 category of unit cell is possible in two-dimensional. One is square unit cell. Second one is rectangular unit cell. Third one is hexagonal unit cell. Fourth one is rhombic unit cell. Fifth one is parallelogram. So that is why in two-dimensional unit cell, we used to call it as a 5 brevis lattice. How many brevis lattice? 5 brevis lattice. Because how many arrangement permutation combination is possible between the parameters? There are 5 permutation combination is possible. That is why 5 brevis lattice is there in two-dimensional unit cell. Then you look at in three-dimensional unit cell. In three-dimensional unit cell, what will happen, my dear? You look at in three-dimensional unit cell, what are the possible? In three-dimensional unit cell, what are the parameters also required you look at, and how many permutation combinations is possible, that we have to look into it. In three-dimensional unit cell, if you look at, suppose I am writing three-dimensional unit cell, 3D unit cell, if you consider this 3D unit cell, if I draw the structure, it will be look like this. This is like a cube, this is a three-dimensional unit cell. It will be like this, this is a three-dimensional unit cell you look at. Now, in between this side is nothing but A, B, and this side is C. Or you can say like that A, B, suppose this is telling A, B and C. And in between angle I am telling alpha, beta and gamma. So this alpha, beta, gamma is called as a interaxial angle, whereas ABC is a length of the different side. A is this side, B is this side, and C is the height, that side length is C. So these are the different side. And by this permutation and combinations, what are the different Bevis lattice is possible, you have to understand. In the book, if you look at it, is very difficult to remember. I am giving you a small tricks. You can remember all the crystal system in a three-dimensional unit cell. First you write down like this, CTO, RH, MT. What you will write? CTO, RH, MT. Then you write down 0, 1, 2, 0, 1, 2, 2. What I told, first you write down CTO, RH, MT, 0, 1, 2, 0, 1, 2, 2. Then 0 means there is no inequalities there in between the side. A will be equals to B, will be equals to C. And then alpha will be equals to beta, will be equals to gamma, will be equals to 90 degree. Because you know, to define a 3D unit cell, there are 6 parameters is required, A, B, C, alpha, beta, gamma. Whereas alpha, beta, gamma is a interaxial angle, whereas A, B, C is nothing but the different side of the cube. And now you look at 1 means there is one inequality is there. A equals to B, B not equals to C. But alpha will be equals to beta, will be equals to gamma, will be equals to 90. And 2 means there are 2 inequalities there. A not equals to B, B not equals to C, alpha will be equals to beta, will be equals to gamma, will be equals to 90 degree. Now when it's coming R, that means no inequality is there. A will be equals to B, will be equals to C, alpha will be equals to beta, will be equals to gamma, is not equals to 90. And now this one is nothing but one inequality is there. A equals to B, not equals to C, alpha will be equals to beta, will be equals to 90, gamma will be equals to 120. And now you understand this 2 means 2 inequalities there. A not equals to B, B not equals to C. So then alpha will be equals to gamma, will be equals to 90, beta not equals to 90. So these things you have to understand. And now the last one. A not equals to B, B not equals to C, alpha not equals to beta, not equals to gamma, not equals to 90. So then in case of this one, we write down these things. And the name is nothing but this is called as a cube. This is called as a what? This is nothing but a cube, simple cube. This is called as a tetragonal. Tetragonal, this is called as a orthorhombic. Orthorhombic, this is called as a rhomohedral. Rhomohedral, this is called as a hexagonal, this is called as a monoclinic, this is called as a triclinic. So that is why you can easily write down these combinations. You need not to mug up these things, very difficult to mug up. So that is what I make you, very simple idea. First you will write CTO or HMT, 0, 1, 2, 0, 1, 2, 2, and then 0 means there is no inequalities there in between the side. 1 means 1 inequality, 2 means 2 inequality, 0 means no inequality, like that is there. And then first 3, alpha will be equals to beta, will be equals to gamma, will be equals to 90. And then fourth one not equals to 90. Third one gamma equals to 120. And then this sixth one beta not equals to 90. And then the last one alpha not equals to beta, not equals to gamma, not equals to 90. And now if they told you most unsymmetrical, which one? Triclinic. There is no similarities there. A not equals to B, B not equals to C, again alpha not equals to beta, not equals to gamma, not equals to 90. That means the most unsymmetrical will be there. Which one? Triclinic. Like in 2D unit cell, parallelogram. So like that you have to understand. So once you understand these things, then we will go for the different classifications of a unit cell. So let us focus on that classifications. So then in that classification, if you focus, this 3D unit cell can be classified into two. One is primitive and one is non-primitive unit cell. This is a primitive unit cell, and this one is non-primitive unit cell. And this primitive unit cell example is simple cube. Primitive example is simple cube. We will write in short form SC. SC means not scheduled caste. We will write down simple cube. Okay. And then non-primitive unit cell, there are three categories there. One is FCC, face-centered cubical system, or it is called as a CCP, cubic closed pack system. Both is a same thing, name is a different. Face-centered cubical system or cubic closed pack system. And the next one is BCC, body-centered cubical system. And then third one is EC, end center cubical system. So that is why there are categories there. What we need to know, three-dimensional unit cell in categories into two categories. One is primitive unit cell, another one is non-primitive unit cell. This primitive unit cell can be only one category is there, simple cube. And then non-primitive unit cell, there will be three category will be there, face-centered cubical system or cubical closed pack system. BCC, body-centered cubical system. EC means end-centered cubical system. So these are the classification is there, and I hope you understand these things. And the next class we will continue in a simple cubical system. Where will be the position of atom, what will be the effective number of atom, all those things we will discuss, and then we will proceed accordingly. I hope it is clear to everyone. So thank you very much. Thank you all.